In this video, we will focus on several methods of splicing two wires together to make a quality electrical repair. Many intermittent drivability and erratic electrical issues are often traced back to a poorly performed electrical splice. The key to a successful butt splice is to use a quality tool, the right technique, properly prepared wires, and the correct gauge butt connector to match the wires being spliced. There are many methods of splicing wires. In this video, we will focus on splicing wires using insulated and non-insulated butt connectors. Both insulated and non-insulated butt connectors are usually available in three color-coded wire gauge ranges as illustrated in this graphic. Insulated connectors are available in non-heat shrink vinyl and nylon versions and also heat shrink style versions as illustrated in this graphic. Crimp with heat shrink style connectors offer a good combination of electrical and mechanical connector integrity, sealing against moisture and fluids, and ease of use. There are also insulated and non-insulated step-down connectors for joining two different gauge wires. For example, when replacing a failure-prone OE blow motor resistor pigtail with a heavy-duty, high-temperature pigtail that uses heavier gauge wire than the original. Here are a few general tips that apply to most wiring splices. If you are going to use heat shrink tubing, which is necessary on non-insulated connectors, but recommended on any type of connection, be sure to slip it over the wire before making the connection. You want to use the smallest size tubing that will slip over the wire and then back over the final splice at the end. Select the smallest gauge connector that will fit snugly over the wires. If you are not satisfied with the match between the gauge of the wire and the connector, consider stripping a longer section of the insulation and then fold the strip section over to get a fuller fit in the butt connector. In this example, we are splicing a new, heavy-duty, high-temperature blow motor resistor pigtail to the vehicle harness on a Chevy van. We will select a step-down connector since the new pigtail wires are a heavier gauge than the original vehicle wiring. Preparing the wires is the same regardless of the type of connector being used. Strip about 1/4 inch of the insulation from the end of each of the wires using a quality stripping tool. Be careful not to nick the strands or stretch the insulation. You can also gently twist the end of the wires to make it easier to insert the wires into the connector. The tip of each stripped wire should not reach past the center of the connector barrel, and the insulation should almost touch but not enter the metal of the connector barrel. Use a quality crimping tool, similar to the one shown here. A quality tool has wide crimping jaws and restrains the diameter of the connector as it is being crimped. Either of the tool styles shown here will produce a much higher quality crimp. Note the thickness of the tool jaws. Ideally, the different connector types call for custom crimping jaws designed for that specific connector style. This tool has a ratcheting mechanism that enables the connector to be held gently in the jaws while the wire is inserted into the barrel of the connector. An inexpensive crimping tool, like the one shown here, simply squishes and flattens the connector, resulting in a loose crimp with excessive resistance that will separate easily. Squeeze the handles firmly, all the way until the ratchet releases. Check that the connection is secure. Use a heat gun with a reflector tip rather than a torch to shrink the tubing. This method distributes the heat more evenly and avoids damaging the connector insulation or adjacent components. When splicing multiple wires at the same location in a tight space, stagger the splice joints to lessen the bulk of the overall repair. Now let's make a splice using crimp with heat shrink insulated butt connectors. Preparing the wire is basically the same, but use the custom crimping jaws for these types of terminals. Position the butt connectors in the appropriate slot in the tool jaws. The tool jaws should just cover half the barrel end being crimped. Insert the wire into the connector as we described previously. Squeeze the handles firmly and check that the crimp is secure. Now repeat for the wire on the other side of the connector. Heat shrink the connector until it forms a snug, weatherproof seal around the wire. And so, in conclusion, for a comeback-free electrical repair, use a quality tool, the right technique, properly prepared wires, and the correct gauge butt connector.